Did you know a giant cruise ship weighing thousands of tons can effortlessly float on water? This marvel of engineering is possible due to a fascinating scientific principle called buoyancy. Understanding buoyancy unlocks the secrets of why some objects float and others sink. Buoyancy is the upward force that a fluid, like water, exerts on an object submerged in it. Imagine jumping into a swimming pool. You feel lighter in the water. This is because the water pushes you upward, counteracting gravity's downward pull. The amount of buoyant force acting on an object depends on two crucial factors. First, it depends on the volume of the object submerged in the fluid. A larger object submerged displaces more fluid and hence experiences a larger buoyant force. Second, it depends on the density of the fluid. Denser fluids like salt water exert a greater buoyant force than less dense fluids like fresh water. The scientific explanation for buoyancy lies in Archimedes' Principle, named after the ancient Greek polymath, Archimedes. This principle states that the buoyant force acting on a submerged object is equal to the weight of the fluid displaced by the object. Let's break this down. When an object enters water, it pushes aside or displaces a certain amount of water. This displaced water has weight, and according to Archimedes' principle, the upward buoyant force on the object equals the weight of this displaced water. If the weight of the water displaced by an object is greater than the object's weight, the object will float. Conversely, if the object weighs more than the displaced water, it will sink. This explains why a dense object like a rock sinks, while a less dense object like a cork, despite its smaller size, floats. You can easily witness the magic of buoyancy with simple experiments at home. Fill a basin with water and gather a few objects of varying densities, such as a cork, a plastic toy, a metal spoon, and a small rock. Carefully place each object into the water. Observe which objects float and which sink. You'll notice that objects less dense than water, like the cork and the plastic toy, float. In contrast, denser objects like the metal spoon and the rock sink. For another experiment, try this. Take two identical sheets of aluminum foil. Crumple one sheet into a tight ball and shape the other into a boat-like structure. Place both in the water. The crumpled ball sinks, while the boat-like structure floats. This demonstrates that the shape of an object and the amount of water it displaces also affect buoyancy. The principle of buoyancy is fundamental to the design and operation of various real-world applications. Ships, despite their massive size and weight, float because their hulls are designed to displace a vast amount of water. This displacement creates a buoyant force large enough to counteract the ship's weight. Submarines, on the other hand, control their buoyancy to dive and resurface. They have ballast tanks that can be filled with either water or air. When the ballast tanks are filled with air, the submarine becomes less dense than water and floats. To dive, the tanks are filled with water, increasing the submarine's density and causing it to sink. Even hot air balloons utilize buoyancy. The hot air inside the balloon is less dense than the surrounding cooler air. This difference in density creates an upward buoyant force that lifts the balloon and its basket. So, the next time you see a ship majestically sailing on the ocean, a submarine gracefully diving beneath the waves, or a hot air balloon soaring through the sky, remember the fascinating science of buoyancy at play.